Hey guys, today we are going to start a three-part conversation that will lead us eventually to being able to find the area of a regular polygon. So let's start with some vocabulary terms. The center of a polygon is the center of the circumscribed circle. Okay, a circumscribed circle is one that is drawn around a polygon. So here's my polygon. The circumscribed circle is drawn around it so that the circle touches every vertex of the polygon. So this is the circumscribed circle for this polygon. The radius of a polygon is the radius of a circumscribed circle. So here in this picture, this point right here, the center of that circle is also the center of the polygon. And this radius of the circle is also the radius of the polygon. An apothem of a polygon is the distance from the center to any side of a polygon, and it is the shortest distance, which means it is the perpendicular distance. So right here from the center to a side, perpendicular to that side, is an apothem. A central angle is an angle formed by two radii drawn to consecutive vertices of the polygon. So this right here is a central angle. So those two radii have to be drawn to consecutive vertices, so vertices right by each other. If I used this radius and this radius over here, that wouldn't be a central angle because it skips a vertex. So it has to be two consecutive vertices that those radii extend to. In this diagram, ABCD is a regular pentagon inscribed in circle F. So the pentagon is inscribed, the circle is circumscribed. Identify each part and find each angle measure. So we will identify point F. Point F is a center. Segment BF. From B to F, that's from a vertex to the center, that is a radius. Segment AF, from A to F, that's another radius from a vertex to the center. Segment GF, GF goes from a side to the center, and the segment is perpendicular to that side. That is an apothem. Angle BFA, BFA, where F is the vertex. Okay, that is made up of two radii that go to consecutive vertices. That is a central angle. And angle BFG, so it's a radius and an apothem that make up this angle, and that we're going to call a half central angle. Now this half central angle is actually going to be a very important concept as we progress toward finding the area of a regular polygon. So now let's find some angle measures. The measure of angle AFB. Now if I was to take this central angle and this central angle and this one and this one and this one and add all of those central angles together, I would get 360 degrees. And there happen to be 1, 2, 3, 4, 5 of them. So if I take 360 divided by 5, I will get the measure of that central angle. So 360 divided by 5 is 72. So that central angle is 72 degrees. The measure of angle AFG, now that is a half of a central angle. So all I have to do is take that central angle and divide it by 2, and that will be 36 degrees. Okay, so again we have here a half central angle, and that is a very important angle to deal with as we work toward finding area of a regular polygon. Next is the measure of angle GAF. Okay, now if I have 90 here and I have 36 here, I can do 180 minus 90 minus 36. And that is 54 degrees. Now we could remember that if I have a 90-degree angle, then all I really have to do is 90 minus 36, because 180 minus 90 is 90. So when I have a right angle and one of the angle measures other than the right angle, all I have to do is 90 minus this one, and it gives me this one here at 54 degrees. Okay, so that would just be a little shorter way of doing it. In the diagram, WXYZ is a square, which is a type of regular polygon, inscribed in circle P. Identify the center. The center is point P. A radius. I could use PY as a radius, or I could use PX as a radius. An apothem. PQ is an apothem, goes directly to a side. And a central angle. Central angle would be right here at vertex P. I have XPY or YPX. Angle XPY, or I could turn that around as angle YPX. Okay, now find the measure of angle XPY. So we're going to find the measure of this central angle. Now, how many central angles could I make? So I've got one central angle here. I could make another central angle here, that's 2. I could make one here, that's 3, and here is 4. So to find the measure of one of those central angles, I can do 360 divided by the number of central angles, which is 4, and 360 divided by 4 is 90. So the measure of angle XPY is 90 degrees. Next is the measure of angle XPQ. Okay, XPQ is this right here, XPQ. That is a half central angle. So all I have to do is the central angle divided by 2, and that is 45 degrees. And last I have the measure of angle PXQ. So the measure of angle PXQ, that's this angle right here. If this is 45 right here, I can just do 90 minus 45. Or I can do 180 minus 90 minus 45. Either way, I'll get the same thing. I'll get 45 degrees.